So today we're going to cover a metrics-based way to look at low power methodology. I'll introduce all the folks, but we've got myself in the Calypto Systems Division, which has HLS and low power. We have Gabriel, who we just walked out. Okay, we'll introduce him in a minute. Looking at all the verification side, and Guillaume, who's going to be looking at the med and emulation side. So really looking at a methodology from the beginning of RTL all the way into SOC verification. So I'll start off with just a quick introduction to set the stage. I don't know if you guys have ever seen the surveys that have been done. These are done by Wilson Research across, it's not particular to Mentor Graphics. It goes across from Cadence users to Synopsys users. And this one was interesting because these get done every 2 years. And with this survey, now power is being the #2 cause of respins. And I don't know for you guys in the room if you started seeing that already, whether you've got a power glitch, whether you're above your power budget, whether you're not competitive, but that has increased dramatically in the last couple of years. And I think we're going to see that continue to grow. So that's #2 right behind logic and functional bugs. Especially also in markets like 5G, smart IoT. If you look at 5G, obviously that has ultra low power. It has everything from very high bandwidth, high performance, which you need to keep the power low in those performance, to ultra low power, basically on the, on kind of the next generation of narrowband and IoT and all these smart devices. And then, of course, if you're looking at the path to autonomous vehicles and autonomous anything, right now, that's a tremendous amount of compute power that is required, but then it can't be, have 10 batteries in the trunk of your car in order to do this. So low power is going to be driving a lot of key markets. So in this tutorial, we're going to be talking about a couple of different aspects of power. So I want to make sure that that we're clear about some of the terminology, right? So leakage power, so the amount of power that is basically going through the circuit when it's turned off, right? So as we've moved, the higher nodes from 28 and above have much more natural leakage power, and then people have moved to FinFET to try to reduce that. But then as you get lower and lower, then the leakage power becomes also still a problem. And then dynamic power, which is the power of the circuit when it's switching. So as we get ready to talk about ways to both measure and reduce both of these things and to have metrics for them, you need to say, okay, which one am I talking about today? So in power estimation, you need to make sure that you are reporting both of them. So you need to report the leakage power plus the dynamic power, then that is the total power. In power reduction, there's going to be different techniques to reduce each of these, right? For example, Gabriel will talk about power management. So you are going to be shutting down, or you have DVFS. You have different kinds of techniques to lower the voltage or to turn off the voltage to therefore reduce the leakage power. On the dynamic power side, to reduce the dynamic power, you need to reduce the amount of switching. And so in order to reduce the switching power, you need to have RTL that functions the same, but still, is not switching when it doesn't need to. So today we're going to talk about metrics about all of those things, how to measure those things, and how to kind of get the lowest power possible in both of these areas. So we want to introduce kind of a graphic way to look at this to kind of guide you through the tutorial. So, on the left here, we have power analysis. So as I was talking about, one of the major metrics are going to be the power consumption. So the analysis is going to be, really how much power are you using? How much power are you wasting? Where can I save more power? And then on the right, low power verification. And in that context, it's going to be verifying your power management and your power intent. So really verifying the circuitry that you have that, with UPF or however you're doing that is verifying your power management intent. So we've got power consumption across the top, both measuring and verifying. And then metrics like, density and efficiency, excuse me, for looking at the power analysis side. And then UPF, checking and coverage and violations, those kinds of metrics for looking at the verification side. So really, we're going to talk about all these different kinds of metrics that you should be measuring, kind of where in the cycle you should be measuring. This is just I know this is pretty a simplistic view, but a simplistic look at kind of the life cycle for low power design. In the beginning, when you're doing block and IP level, you've got RTL designers. They need to be using low power techniques in order to do their RTL. So those are well documented techniques in many of them. And in some of the ones I'll talk about today, maybe not as well documented. As you begin to get higher level in the RTL, farther along in the RTL, you can measure the power of your blocks, measure the power of your subsystems. At the same time, you're also beginning to look at your power management infrastructure, your power controllers. So as you kind of go through that, and as you bring up the full SOC, you need to be able to measure your SOC power, right? So you've got some metrics. Perhaps you have, kind of block and subsystem kinds of metrics where you say, okay, I've got a power budget for this block. But then also when you get to the SOC, that's really where the rubber hits the road to see whether in different real scenarios you've really made your power budget. So again, taking this to look at metrics, you've got in the early days, the best you can do, you've got early power metrics. Perhaps many of the companies we talk to, they don't have simulation vectors yet in the very early. They want to be able to say, okay, how is my RTL for power? But I don't really have good scenarios yet for power. So I want a way to be able to measure the quality of my RTL for power, like I'm doing now with coverage, like I'm doing now with all your other metrics. What's the quality? And then as you move up, you'll then begin to have functional simulation vectors. So you'll be able to say, okay, I can measure both the consumption and more efficiency. As I get farther along and I've begun my verification, then I can begin to look at power management metrics. So the coverage, have I covered all states in my power management? Have I verified it properly? And then as we get bigger and start putting together bigger SOC designs, I want to look at SOC power management metrics. So look at the whole UPF along with the software and everything in the controller. And then at the end, I really need to measure the power of the full SOC under critical scenarios, because oftentimes that is where your product is going to be measured, is can you meet the power requirements of running certain critical benchmarks. So kind of, I think you need to look at this very holistic from the beginning to the end in order to get to the end and meet your power budgets and have a competitive product.